particular directions, which we have already learned. What is the advantage of that? What is the advantage of resolving vectors in 2 dimensions? Okay, for example, what is the advantage? The advantage is that the x component has nothing to do with the y component, and the y component has nothing to do with the x component. So we can treat 2 directions as independent directions, and we can treat them as 2 independent one-dimensional motions. Is that right? Alright, for example, let's say if I roll a ball in this direction, alright, I roll a ball in this direction. Until and unless the force is perpendicular to the direction of ball, the ball is not going to move in that way direction. Is that clear? Okay. If the ball isn't rolling like this, I keep pushing the ball in the same direction. I apply the force in this direction. Okay. Do you think the direction of motion of the ball is going to change? It's not. Okay. Unless and until I have a component of force which is perpendicular to this direction. Alright, for example, if I now apply the force which is at an angle like this. Alright, the ball is being rolled here and I'm applying a force at an angle like this. Alright, do you think the direction of motion will change? The direction of motion of the ball will change. Why? Because now this force, I can resolve it in 2 directions. Which direction? This direction and this direction. Alright, now what will this do? This will increase the velocity in this direction. Okay, I'm pushing the ball, so this will increase the velocity in this direction. Alright, now the ball did not have any velocity in this direction. Is that right? It is moving in this direction, so the ball does not have any velocity in this direction. Now a component of the force is perpendicular to the ball, so it is also going to give certain velocity in this direction also, so the ball should start moving in this direction also. Okay, so if I apply a force in this direction, how do you think should the ball move? The ball is going to move at an angle. Alright, at an angle. So that means now ball does have a velocity which is in this direction. Is that clear? If I don't apply a force in this direction, the direction of the ball will never change. Is that right? What does that mean? That the x motion has nothing to do with the y motion, and the y motion has nothing to do with x motion. Is that clear? So anything we have, any 2-dimensional motion we have, we can resolve them into 2 components, and we can treat both the components as independent one-dimensional motions, and then we can apply all the equations we know for one-dimensional motion. Is that clear? That is the bottom line of this exercise that we are going to do. Alright? Okay, so let's get started. Can I write the position, if I'm dealing with 2 dimensions, can I write the position vector as xi plus yj, where x and y are the x coordinates and y coordinates? Okay. What if I differentiate position with respect to time? What should I get? Should I get velocity? Okay. Now I'm differentiating these 2. They are separated by a plus sign. Okay. So that will be the differential of x into y, and that will be the differential of y into j. Okay. What is the differential of x with respect to time? What is dx by dt? That will be the velocity. That will be the velocity. But which velocity? The velocity in the x direction. Okay. So this is the change in the x coordinate with respect to time. So that is only going to give me the x component of the velocity. Is that right? So I can write it as vx I cap, and I can write this as vy j cap. Is that clear? Okay. I differentiate it again. If I differentiate again, what do I get? I get acceleration. Alright. Again, if I differentiate the x component of acceleration, what should I get? I should get the x component of the acceleration. Is that right? If I differentiate the x component of the velocity, I should get the x component of acceleration. So what would I get? I get ax I cap plus ay j cap. Is that clear? So what do you see? The x component has nothing to do with the y component, and the y component has nothing to do with the x component. Okay, so all we need to do is resolve the vectors in x and y directions and treat them independently. That's it. Is that clear? Okay, let's take an example. I think it's there. Okay, look at page number 10, question number 1. Page number 10, question number 1. Look at that. Page number 10, question number 1. So basically what is happening, the acceleration is constant, and it's 1.5 meter per second square, making 37 degree with x-axis. Is that right? What is the direction of velocity? The direction, a particle in the xy plane with a constant acceleration in a direction making an angle 37 degree with the x-axis. Alright. And the alright. At t is equal to 0, the particle is at its origin and its velocity. Now what is the velocity? Velocity is 8 meter per second, making an angle 30 degree with the x-axis. Okay, we need to find the velocity. And the position of the particle at t is equal to 4 seconds. Is that clear? Okay. So how we are going to do is, we are going to divide this into two components. The first one would be the x component and the other will be the y component. Alright, so I want to resolve everything, the displacement, the velocity, the acceleration, everything I can divide it into two components. Alright, so I'm going to write ux. What do you mean by ux? So this is not actually v, this is u, the initial velocity. Ux means what? The x component of the initial velocity. What will be the x component of the initial velocity? U cos 30 degree. U is making an angle 30 degree with the x-axis, so the component along x-axis will be u cos 30 degree. Is that right? Initial velocity is 8 meter per second. At t is equal to 0, particle is at origin, that is the position, and its velocity is 8 meter per second, making an angle 30 degree with the horizontal. That is the velocity. Okay, the position is 0. Alright, so ux is what? Hang on. Alright, so ux would be how much? U cos theta. Ux will be u cos theta, and u cos theta is how much? 8 cos theta. 8 cos theta matlab cos 30 degree. Cos 30 degree is root 3 by 2, yani ki 4 root 3. The unit is meter per second. Alright, what will be the y component of the initial velocity? U sin theta, and that will be 8 into sin 30 degree, yani ki 4 meter per second. Correct? Okay, similarly what can I do? I can resolve acceleration also. Take it. So what will be the x component of the acceleration? That will be a cos 37 degree. Is that right? So that will be how much? That will be 1.5. What is cos 37 degree? What is cos 37 degree? Cos 37 degree is 4 by 5. So this will be how much? This will be 1.2 meter per second square. What will be the y component of the acceleration? Y component of the acceleration would be a sin 37 degree. So that is 1.5 into sin 37 degrees 3 by 5. So that will be 0.9 meter per second square. Is that right? Okay. Now what do I need? What do I need? I need the position and the velocity. I need the position and the velocity. So first of all, the time taken is the same for both the x motion and the y motion, because this is only one motion, and it takes how much? T is equal to 4 seconds. Is that right? Now if I need to find the final velocity, okay, can I use Vx is equal to ux plus ax into t? Because the x component, I can treat it as one dimensional motion. I have resolved everything. Now I can now I can use the x component. I can assume the x component to be in one dimension. Take a one dimensional motion. Take it. For one dimensional motion, can I write this equation? So what is Vx? Vx is the final velocity, but which final velocity? The x component of the final velocity. So I can write this as Vx is equal to ux plus ax into t. Is that right? Similarly, I can write Vy is equal to uy plus ay into t. Is that right? Clear? Now substitute everything. So ux is how much? Ux is 4 root 3. Ax is 1.2 and t is 4. Similarly, how would we find Vy? We'll find Vy as uy is how much? 4 plus ay is how much? 0.9 into t. Is that clear? So that will be Vx and that will be Vy. Okay. So how can we write the final velocity? So the question is find the final velocity. So how can we write the final velocity? Can I write the final velocity as Vx I cap plus Vy j cap? Is that correct? We have calculated Vx, we have calculated Vy. Can I write the final velocity as Vx I cap plus Vy j cap? I can write that. Okay. If the speed is required, how do you find the speed? We'll take the magnitude of the velocity. We can take the magnitude of the velocity, that will give me the speed. What will be the speed? The speed will be Vx square plus Vy square ka under root. Correct? If it is required, what is the direction of motion of the particle? Vy by Vx. Excellent. If it is required, what is the direction of motion of the particle? I can say tan alpha is equal to Vy upon Vx. Is that right? Tan alpha will be Vy upon Vx. So that's that alpha will be the direction of velocity with the x-axis, the angle the velocity makes with the x-axis. Is that clear? Okay. Next, I need to find the position. Okay, so what do I need? I need x. So it started with 0. If I find the position, that will also be the displacement. Okay. So can I write x is equal to uxt plus half axt square? Correct? Take it. So this is going to give me what is ux? Ux is 4 root 3. What is the time? Time is 4 plus half into 1.2 into 4 square. Is that clear? So I found x. How do I find y? Y will be uyt plus half ay into t square. Is that clear? So this will be equal to how much? Uy is 4, then 4 into 4 plus half into 0.9 into 4 square. Alright, so I know the x coordinate and I also know the y coordinate. So how can I write the position? How can I write the position? The position will be x I cap plus y j cap. I have calculated x, I have calculated y. I can write the position as x I cap plus y j cap. If the displacement is required, so this position is also the displacement because you started from origin. So this position is also the displacement. So if the magnitude of displacement is required, you take the mod. And if the direction, find the direction of displacement is required, you know what to do. Tan alpha is equal to y by x. Is that clear? And that's it. That's all you need to do in two-dimensional motion. Resolve it in two perpendicular directions, mutually perpendicular directions, and treat both of them as one-dimensional motion. And one-dimensional motion, we also know quite a bit. We know quite a bit of one-dimensional motion. Alright? Clear? Any problem? Pakka? Okay. Note this down if you want. And try question number 2. right? You get that? So find the displacement of the particle and the velocity with which it strikes the ground. Okay, you can take g as 10 meter per second square. You can take g as 10 meter per second square. All right. So how is it going to fall? Something like this. Something like this. Is that right? Okay. So what is required? The displacement of the particle. What is the displacement of the particle? This is the displacement of the particle. Is that right? So I need to find out the displacement of the particle and the velocity with which it hits the ground. Okay, so the velocity over here would be at an angle. Is that right? The velocity would be at an angle. It is going like this. Clear? The velocity would be at an angle. So I need to find that velocity and I need to find this displacement. Alright. So what should I deduce or what should I calculate to calculate these things? What is given to me? This is given to me. This is 10 meter. This is 10 meter. Okay. So if I find this horizontal distance, my job is done. Okay. And I have to find the velocity. So if I find Vx and if I find Vy, my job is done. Is that clear? That's all we need. We need this horizontal distance and we need Vx and Vy. That's it. Alright. So I can break this motion into two components. Alright. So the choice is yours. How do you want to take the x-axis? How do you want to take the y-axis? Okay. I would do it something like this. I'll take this as the y-axis and I'll take this as the x-axis. My choice. X-axis and y-axis. Alright. So from this convention, the convention I am using, x-axis, y-axis, the axis I am using, tell me what will be ux. Tell me what will be ux. 10 meter per second. Excellent. 10 meter per second. Why 10 meter per second? Because it is being thrown horizontally. It is being horizontally. So if it is being thrown horizontally, the x component is 10 meter per second. What will be the y component? 0. That's it. Clear? Alright. It is making an angle 0 degree. So 10 cos 0 degree will be 10. And 10 sin 0 degree will be 0. Alright. Tell me what will be ax. 0. Because the gravitational force is going to act downwards. The acceleration due to gravity is downwards. Is that right? So does the acceleration have any component in the horizontal direction? It does not. Take it. So this becomes how much? 0. What is Ay? 10 meter per second square. The acceleration due to gravity is along the y-axis. Is that clear? Okay. What else do we know? What else do we know? We know the y displacement. Do you know the y displacement? 10 meter. So it has fallen like this. So what is the displacement which has taken in the y along the y-axis? It is this. And plus 10 meter. Okay. What is x? I need to find out. What is x? I need to find out. And what is Vx and Vy, that is something I need to find out. Alright, okay. Now I have this, I have this, I have this. Can I calculate the time taken for the fall? What should I use? What should I use? X is equal to uxt plus half axt square. Is that right? Sorry, y. Sorry. Y. Y is equal to uyt plus half ayt square. Is that right? I can use this equation to find out the time taken for the fall. So y is how much? Y is 10. What is uy? Uy is 0. So this becomes half into ay is 10 into t square. Is that right? So the time taken is how much? 10 root 2 second. Is that clear? Any problem? Okay, so I'm using, I know all these things. Now I'm using y is equal to uyt plus half ay t square. So I can find time from here. Okay. Yeah. Oh, sorry, only root 2. Yes, you're right. Only root 2. So the time taken is root 2 second. Okay. Now tell me, for the x motion also, the time taken would be the same. Because the same particle, whatever time it takes for the y component motion, that will be the same as its x component motion. Take it. So how much time has it traveled? It has traveled root 2 second. Alright. Now can I find x? How can I find x? X will be equal to Vx into, or I can write ux into t. Why ux into t? Because there is no acceleration in the horizontal direction, right? If there is no acceleration in the horizontal direction, if there is no acceleration in the horizontal direction, I can use s is equal to vt. Displacement is equal to velocity into time. Is that clear? Okay. Matlab I'm writing this. But what is the acceleration in the x direction? Nothing. So can I write x is equal to ux into t? Right? So x is equal to ux. How much is ux? Ux is 10. And then what is t? T is root 2. So x is equal to 10 root 2 meter. That means this distance is root 2 meter. Is that clear? Any problem? Alright. Now what is my next objective? My next objective is to find ux and, sorry, vx and vy. Alright. Arre yaar, haan. Yes, 10 root 2. Okay. Now the next objective is to find vx and vy. How do I find vx? Tell me, how do I find vx? Excellent. Vx is equal to ux plus ax into t. Okay. Now what is ax? 0. Ax is 0. Okay. So Vx is equal to what? Vx is equal to ux. How much is ux? Ux is 10 meter per second. Now understand this. If there is no acceleration in the horizontal direction, should the velocity change in the horizontal direction? It should not. Okay. So I don't even need to calculate this. If there is no acceleration in the horizontal direction, the horizontal velocity will remain constant, and which it has. Is that clear? Okay. So what do I get? I get Vx. I get Vx. That is the x component of the velocity. And that is how much? 10 meter per second. Now how can I find the y component of the velocity? Same. Vy is equal to uy plus ay into t. So this will become Vy is equal to uy is 0. And then ay is how much? 10. And t is how much? Root 2. So this becomes 10 root 2 meter. Sorry, meter per second. So the y component of the velocity is how much? 10 root 2 meter per second. Is that clear? Okay. So can I write the displacement? Can I write the magnitude of displacement as x square plus y square under root? And that will be 10 root 2 square plus 10 square ka under root. So that will be how much? That will be 10 root 3. Any problem? Okay. Now how can I write the velocity? Can I write the velocity as 10 I cap plus 10 root 2 j cap? Can I write the velocity as? The velocity will be 10 I cap plus 10 root 2 j cap. Alright. Now if the speed is required, the magnitude of velocity will be equal to what? 10 square plus 10 root 2 square, again how much? 10 root 3 meter per second. Correct? And if it is required, what is the angle with which it is hitting? If that is also asked, what is the angle with which it is hitting? So this is the angle with the horizontal with which it is hitting. And can I write that as tan alpha is equal to Vy upon Vx? Is that clear? That's all we need to do in two-dimensional motion. Clear? Which last part? This part. Velocity is 10 I cap plus 10 root 2 j cap. How do I find the magnitude of velocity? It's the x component square plus y component square under root. So that will be 10 square plus 10 root 2 square under root. That's it. Clear? Alright, so you may try question number 3. Huh. Yeah, he thought so. Yeah, he aimed at his friend and threw the packet. साइंटिफिक कैलकुलेटर क्यों चाहिए कैलकुलेटर? थीटा के लिए कैलकुलेटर चाहिए तेरे को? थोड़ा सोच तो. And you cannot use a calculator. Understand this. In any of the competitive examinations, you are not allowed to use a calculator. You don't know this? Really? Alright, so you cannot use a calculator, so don't get into the habit of using calculators. Okay? And it's not that they don't ask calculations. The calculations can get messy. Alright? So be in the habit of doing it on your own. Especially in chemistry. Chemistry, you have to do a lot of calculations. Right? You have to do that. You have to practice that. You can take GS 10. See, everything is in feet and feet per second. Everything is feet and feet per second. So it would be better if you take 32 feet per second square. Okay, that is the situation. That is the situation. Alright. So obviously if this guy is aiming in this direction, you know it is never going to reach that guy. Alright, so because gravity exists. So it is going to fall something like this. Right? It is going to fall something like this. Alright. So you need to find out how short has it fallen. That means basically what do you need to find out? You need to find out this distance. That's it. You need to find out that distance. No, the aim is in this direction. Alright. But do you think it is going to hit that? It is going to go in this direction. The gravity is going to pull it. So it is going to fall short. This distance is 228 feet. The person is here. You get this? Is that clear? Okay, if you aim horizontally, okay, for example, if you aim to hit it there, okay, you'll throw it horizontally. You throw it horizontally. Is it ever going to hit it? It is always going to fall short. Correct? Because gravity is going to pull it down. Okay, so what do we need? We need to resolve it. Basically resolve it. I know you have trouble finding out theta, right? Okay. This is theta, so I'll choose x-axis like this and I'll choose y-axis like this. It's logical. Okay, so I need to find out this angle. If this angle is theta, this angle is also theta. So tan theta is how much? Tell me. Tan theta is 171 upon 228. Okay. Is it going to get factorized? Divided by 57 by 76. Divide that by 19. 19 3 is a 57. 19 4 is a 76. So this is basically how much? 3 by 4. So tan theta is simply 3 by 4. So that is how much? Theta is what? 37 degree. So you know what is sine 37 degree, you know what is cos 37 degree. Correct? Now try doing it. Yes. $179 I don't know the answer. Let's see. Okay, tell me what will be ux? U cos 37 degree. Is that right? Ux will be, this is theta, so either cos 37 degree, either sin 37 degree. So the x component of velocity will be 15 into cos 37 degree. Cos 37 degree is how much? 4 by 5. So that is 12 feet per second. What is uy? Uy will be 15 sin 37 degree. Matlab 9 feet per second. Ax, excellent. Ay, 32 feet per second square. Everything is feet per second. Let's use feet per second square. Alright. X displacement, do we know? We don't know. That is what we need to find out. Do we know the y displacement? 171 feet. Okay. Using this, what can I calculate? The time taken. So all I need to do is put it into y is equal to uyt plus half ay into t square. So y kitna hai? 171. Uy is uy is 9 t plus half into 32 into t square. So I'll get a quadratic equation, and that will be 16t square plus 9t minus 171 equal to 0. Can I solve this? Let's try to factorize it. So this is 16 and then multiplied by 171. What is 171? We know it is divisible by 57. We've just done that. Matlab it is divisible by 19. So this is 19 into 3 into 3. Is that right? So 57 and 48. Done. 57 and 48. Alright, so this will be 16t square plus 57t minus 48t minus 171 equal to 0. Alright. So one of the times you're going to get minus 57 by 16, which has no meaning. And the next you will get is 48 upon 16, yani ki 3 seconds. Okay, if you factorize it, this is what you're going to get. Okay. Huh? 36. X will be, alright. So x will be how much? X will be equal to the velocity in the horizontal direction to time, and the velocity is not changing because there is no acceleration in the horizontal direction. So this becomes how much? Ux into t. What is ux? 12 into 3. That is how much? 36 meter only. So this distance is only 36 meter. Sorry, feet. Sorry, feet. Feet. Okay, so how short is it? Very short. It's 192 feet short. Huh? Might be. हाँ भागेगा या गिव अप कर देगा. Anyway, is that clear? Okay, but tell me, okay guys, but tell me, if actually he had to transport this parcel to this guy, in which direction should he have thrown it? He would have thrown it something like this. Okay, and that is the next thing we are going to study, and that is projectile motion. Alright, okay, this is alright. Two-dimensional motion, resolve it in two components, solve it like two one-dimensional problems. That's it. Clear? Okay, now let's get into projectile motion. Okay, so the projectile motion, listen carefully. The projectile motion is a special case of two-dimensional motion. Is a special case of two-dimensional motion, and all the things we are going to derive right now are under certain conditions. What is that condition? That it is a ground-to-ground projectile. So you throw something at an angle with the horizontal. You throw something with an angle with the horizontal with some speed. So it is going to go something like this. Is that clear? Okay. So all these formulae that we are going to derive is for ground-to-ground projectile. That is, the projectile starts from ground and ends at ground. It's not that we are going to throw the projectile to a window on a building. Okay? Window of a building. We're not going to do that. Okay? That is not ground-to-ground projectile. Ground-to-ground means it starts from ground and it has to end at the ground. Is that clear? That is one. Second condition is that your ground has to be horizontal. Alright, your ground has to be horizontal. So if you are on a cliff, on a hill, on an inclined plane, we'll have to use different set of things. But for now, we are only talking about ground-to-ground projectile, and where my ground is horizontal. Okay? All the formulae I'm going to derive right now are under these two conditions. If any of these two change, I have to change my equations, and we'll do that. How do we do in those cases? We'll do it, but for now, let's stick to this. Alright? Ground-to-ground projectile and ground is horizontal. Okay. Let's take this as the x-axis and let's take this as the y-axis. Alright. Let's say it is projected with a speed u, which is known as the speed of projection or velocity of projection. The velocity with which it is thrown. And the angle with the horizontal is known as the angle of projection. Remember, angle with the horizontal. That is known as the angle of projection. Alright. So from this we need to find out three things. First of all, we need to find out the time of flight, then we need to find the range, and then we need to find out the maximum height reached. Probably you would be aware of these things, kabhi padha hoga school mein. What is the range? This is the range. The horizontal distance covered is the range, correct? What is the time of flight? The time period during which it was in the air. Okay, this whole thing is the time of flight. What is maximum height reached? This is the maximum height reached. We need to find these three things. All right. Now tell me, is projectile motion under gravity? Yes or no? When it is in the air, what is the acceleration on it? G downwards. That's it. The acceleration is always going to be G downwards. So the projectile motion, can I also say it is symmetric? The projectile motion is also symmetric. What does that mean? What does that mean? So if it goes from here to here in a certain time period, it has to go from here to here in the same time period. That is symmetric. Take it. If at the same height, its velocity is Vx and Vy, at the same height, if its velocity is Vx and Vy, take it. So here it should have the same velocity Vx and same velocity Vy, but the direction of Vy will change. Now it's coming down. Is that clear? So I can say at the same height Vx, so ye bhi Vx, and if this is Vy, this will be Vy. Is that right? That I can say on the basis of symmetry. The time taken to go from here to here will be the same as the time taken from coming from here to here. Is that clear? So all those things, symmetry, the symmetry in motion will be valid in this case also. Is that clear? Okay, now we need to do is, all we need to do is break this up into two components and solve it like it's a one-dimensional problem. Alright, so let's quickly do it. What is ux? Ux will be how much? U cos theta. Uy will be how much? U sin theta. So the horizontal component of velocity will be U cos theta. The vertical component of the velocity will be U sin theta. Okay, what is ax? What is ax? 0, because the gravity is acting downwards. What is ay? Minus g, direction. I've taken upward as positive. I've taken upward as the y-axis. The g is, so acceleration is minus g. Alright, okay. Let's try to find out what is the time taken. Okay, what is the time taken? Okay, what can I say about the vertical motion of the particle? Which equation can I use? Can I use this? Okay. So I'm talking about this point. I'm talking about this point, the final point. What is the y coordinate of the final point? 0. The particle is here. What is the y coordinate? The 0. Okay. So can I write 0 is equal to u sin theta t minus half into g into t square. Ay I'll put as minus g. Alright, I get this. Okay. Now this is a quadratic in terms of t. I solve this, I'll get two answers. One will be t is equal to 0 and the other will be 2u sin theta by g. Is that right? What are these two answers corresponding to? What are these two times corresponding to? Whenever y was 0. When was y 0? Y was 0 over here, the time was 0. And then y was 0 over here, the time was 2u sin theta by g. Now tell me, what is the time of flight? That's it. That is the time taken for it to reach here. Is that clear? Any problem? Okay. So what is the time of flight? The time of flight is 2u sin theta by g. Okay. I can do it in another way. Okay. Can I say that the time of flight is equal to the time of ascent by the time of ascent into 2? The total time of flight is the time of flight, the time of ascent into 2. Because the time of ascent and time of descent will be the same. Okay. So how can I find the time of ascent? U sin theta by g. You are absolutely right. You are absolutely right. How can I find the time of ascent? Till what time is the projectile ascending? Till the time its vertical velocity becomes 0. Is that right? When the vertical velocity becomes 0, is it going to move ahead? I mean, is it going to move up? It's not. ठीक है. So till what time is it ascending? Till the vertical velocity becomes 0. So can I write Vy is equal to Uy plus Ay into t? ठीक है. And that is also the method to find the velocity at any time, if you can realize this. So if it is required, find the velocity, vertical velocity at this time, we can use this. All right. So Vy is how much at the top? Vy is 0. Uy is how much? U sin theta minus gt. So time यहाँ से आएगा u sin theta upon g. So the time is of ascent is the time taken for the vertical velocity to become 0. So if you remember, in the case we threw it upwards, the answer was u by g. Is that right? When we are throwing it upwards, straight upwards, the time of ascent was how much? U by g. What is the difference here? Now the vertical velocity is u sin theta in place of u. That's it. Is that clear? Any problem? Okay. So I can also write it as 2uy upon g. Does that make any difference? Clear? Okay. Next we want to find out the range, the horizontal distance traveled. How do I find the horizontal distance traveled? Vx is not 0. Will not. What can I say about the x motion? The acceleration in the x direction is? The acceleration in the x direction is 0. What does that mean? Constant velocity, that's it. So the horizontal velocity is never going to change. Note this down. For a projectile motion, the horizontal velocity is never going to be different, never going to change. It is always going to be u cos theta. Why? Because there is no acceleration in the horizontal direction. Is that clear? Okay. So can I write x is equal to u cos theta into the time period, or sorry, not the time period, the time of flight? The projectile has moved for time capital T. So what will be the displacement? U cos theta into t. Okay. So I can, and will that be the range? Will that be the range? The distance it travels, the horizontal distance it has traveled in the time, during the time of flight. That is the range. Okay. So I can write range as u cos theta, and what is that? Is 2u sin theta upon g. Clear? Okay. So I can write it as r is equal to u square sin 2 theta by g. 2 sin theta cos theta will be sin 2 theta. Or I can also write it as, what is u cos theta? Ux. U cos theta is how much? Ux. U sin theta is how much? Uy. I can also write it as 2ux uy upon g. This is also a result which comes in handy sometimes. Okay? Clear? Okay, so this derivation, there is nothing to memorize in this. It is only application of two-dimensional motion. That's it. Okay? And this derivation might be, or certainly will be asked in your school examination, if projectile is in the syllabus. Obviously, this derivation has to come. Okay? So it's better you understand this. All right? Next is, how do I find out the maximum height reached? How do I find out the maximum height reached? So this is the maximum height reached. When will the maximum height be reached? When the vertical velocity becomes 0. That's it. When the vertical velocity becomes 0. Okay. So what equation can I use? I'll use the equation for vertical motion. And which equation? I can use Vy square is equal to Uy square plus 2Ay into S, the displacement. So I should write Y. I can write Y. Is that clear? Okay. Substitute. Vy square will be how much? 0. The maximum height will be reached when the vertical velocity becomes 0. Uy is how much? U sin theta ka square. Yes. Into, and this will become minus 2g, and this will be, can I say this is h? Can I say this vertical displacement to be h? This is the point where vertical velocity becomes 0. What is the vertical displacement at that point? H. And that is what we need to find out. Okay. So h becomes what? H becomes u square sine square theta by 2g. Alright. And I can also write it as h is equal to uy square upon 2g. Okay. Remember when I threw the particle straight upwards, what was the maximum height reached? U square by 2g. Is that right? U square by 2g. What is the difference here? The vertical velocity now is uy or u sine theta. That's it. Is that clear? Any problem? Okay. So you don't need to. You do need to note some things down. Okay. So the derivation is almost there. So this you may note. This you may note down. And this you may note down. Okay. We'll see later on why they're useful. But is the derivation clear to everyone? So it's not really a derivation, just the application of two-dimensional motion. Break it into x and y components. Treat them like one-dimensional motions. Clear? Alright. One more thing we need to derive. Can I rub this off? I need to find out the equation of trajectory. What do you mean by equation of trajectory? What is trajectory? Path. So I need to find out the equation of the path. That's it. Take it. Equation of path means what? Y is a function of x. This graph, I need to find the equation for this graph. This is a yx graph. I need to find the equation of this graph. That means what? I need to find a relationship between y and x. Okay, it's very simple. Can I write this? No, I cannot write this. No, this is right. Y is equal to uyt minus half g t square. Is that right? Okay. Can I write this? Because the acceleration in the horizontal direction is 0. Can I write that? Okay. So this gives me t is equal to x upon u cos theta. Now I can substitute it here. So basically what I'm doing is I'm eliminating t. Alright. So this will give me how much? I'm not going to do the calculation. I'm directly going to give you the answer. That will be x tan theta minus gx square upon 2u square cos square theta. Okay? Simple calculation. If you do that, you will get this. Alright? Okay. Now what is the meaning of equation of trajectory? Meaning of equation of trajectory is if you put the value of x, you'll get the value of y. That's it. Okay? So this is a sort of quadratic. You see a quadratic function in terms of x. That means what? Parabola. I know you're obsessed with parabola. Okay. What does that mean? That for the same value of y, I'll get two values of x. Is that right? For the same value of y, I put y something, and I'll have to solve the quadratic. I'll get two. Is that clear? For the same vertical height reached, I'll have two values of x. That is the meaning. You put the value of x, you'll get y. Put value of x, you get y. That is the meaning of equation of trajectory. Is that clear? Okay. Okay. Another way to write it down, and that will be very easy to remember, is y is equal to x tan theta. Take x common, and this will become 1 minus x upon r. R is the range. So you take x tan theta common. Take it. So tan theta will come here. You'll rearrange the terms, and it will come out like this. Okay. So this is very simple to remember. Y is equal to x tan theta into 1 minus x by r. Is that clear? Alright. Okay. Then quickly let's do a few questions. Okay, do question number 1. Page number 12, the last page, question number 1. Try doing that. It's 10, no problem. Take GS 10. Straightforward application of formula. Okay, this is just for you to memorize the formula. Alright. I don't know the answer. You only have to substitute. What's the velocity vector? Velocity is a vector, so velocity vector. Matlab velocity with its direction. Okay, so how did you find h? U square sine square theta by 2g. What is theta? I know you will mess up. Read the question again. Thirty degrees with the vertical. Alright, that's what I said. Be careful. What is theta? When you're using a formula, be careful what is what. Alright, so theta is the angle with the horizontal. We have always chosen the angle with the horizontal as theta. 60 degree, correct. That's it. Alright, then all you need to do is plug into the formula. That's it. Alright, okay. Any problem? This is just formula based. Alright, now go to question number 2. Sorry? A projectile is thrown with a velocity of 20 meters per second at 60 degree. If nothing is given, you'll assume it to be horizontal, with the horizontal. Alright. Did you get the question? So the projectile is thrown like this. It is thrown at an angle 60 degree. Okay. But gradually what will happen to the direction of the motion of the particle? It will be along the tangents to the path. Okay. So here it becomes horizontal. Okay. So the direction, the angle it is making with the horizontal will gradually decrease. Okay. So there will be a time when the velocity will make an angle 45 degree with the horizontal. There'll come a time when it makes an angle 45 degree with the horizontal, right? So you need to find out at what time does this happen. There'll be two answers. You're right. You're absolutely right. You're absolutely right. So if you find one answer, the other answer will be easy. But let's find the first answer. Yes, what is the answer? 2 root 3. How did you get that? Yes. Which formula? No, u sine theta by g is here at the top. Is that right? That is the time of ascent. The time taken from here till the topmost point. But it is somewhere in between. Okay. What should we do? First try and think, what should I get so that I can get to this answer? What should I calculate that so that I'll be able to calculate this time? Alright, agreed. The height, if you calculate the height, so what is given to me? What is given to me? Ux is given to me, Uy is given to me. Is that right? Okay. Ax is given to me and Ay is given to me. Is that right? Okay. So I have Uy, I have Ay. What should I calculate so that I can calculate time? Height is 1, but something else would be easier. I have Uy, I have Ay. What should I calculate so that I can get T? Vy, correct, you're right. If I find Vy, would I be able to get T? That's it. Do you get this? Okay, now how do I get Vy? That is the question. How do I get Vy? That is the question. Is this going to be Vx? And this is going to be Vy? The velocity is like this. So this component would be Vx, this component would be Vy. Is that right? So can I make use of this 45 degree? What? How can I use this 45 degree? Tan alpha is equal to Vy by Vx. Excellent. So I can use tan alpha is equal to Vy upon Vx. Is that right? At this instant, it is making an angle 45 degree. So can I write tan 45 degree is equal to Vy by Vx? Can I write that? Yes. So tan 45 degree is how much? 1. And Vy, I need to find out what is Vx? What is Vx? Vx is 10. Okay. Vx is basically always equal to u cos theta. Is that right? Because the velocity does not change in the horizontal direction. So Vx will always be equal to ux, and that is how much? U cos theta. So what is u cos theta? U cos theta is how much? What is the velocity? 20 into cos 60 degrees. So that is how much? 10 meter per second. Is that clear? Problem solved? Okay. So this will be how much? This will be upon u cos theta. So Vy becomes u cos theta, and that is how much? That is 10 meter per second. Now I have everything to calculate the time. So the time would be how much? Vy will be equal to uy plus ay into t. So Vy is 10, uy is 10 root 3, u sine 60 degree. Uy will be how much? U sine 60 degree yani ki 10 root 3, and then minus g into t. And how much is g? G will be 10, and this is t. Is that clear? So t will be how much? T will be equal to root 3 minus 1 second. Yes, 0.732 second. Is that clear? Is that clear? Any problem? Take it. Would there be another time when the angle is made 45 degree with the horizontal? Which time is that? At the same height. Very good. At the same height. Can I find this time also? How? Yeah? Exactly. Vy will be minus 10. That's it. That is the only difference. So here you substituted 10. There you will substitute minus 10. That's it. Or the time taken from here to here is the same as time taken from here to here. Okay? So what is the time taken from here to here? That is the total time of flight minus this time. That is also what can be done. Okay? So you can use symmetric in various by various means. All right? Is that clear? Look at question number 4. Uh-huh. 1 yard is 3 feet. 1 yard is 3 feet. Uh, but then you'll have to convert everything. So everything is given in feet and feet per second. Use 32. Use 32. Okay, so the question is, it is hit with a velocity of 60 feet, 4 feet per second at an angle 45 degree. The goalpost is 120 feet away. All right. Now the question is the goal going to happen or not? Okay. How can we say that the goal was scored or it was not scored? Uh-huh. So it should have specified that the ball directly has to go into the goal post. It should have clarified, because even if I kick it slowly, rolling, it'll reach the goal post. All right. But that is not the question. The question is, it has to get into the goal post directly. All right. So how should I understand that the ball would go into the goal post or not? Yes, you're right. Take it. So what can happen? It can go like this. If goal is being scored, the ball should be either here, or here. What do you understand? When the horizontal displacement is 120 feet, the vertical height should be less than 10. That's how we can understand that the goal was scored or not. Is that clear? Correct. So at 120 feet, what will be the height? Can we calculate that? And then we can find out goal took place, or the goal was scored or not. Is that clear? Okay, try doing it. H max. No, why should h max be 10? It is not said that the goalpost is being placed at the center of the range. It could be anywhere. Range could be. Range could be. See, range is not going to decide. Understand this. Range is not going to decide. Take it. So you are telling me this is the range? Can't I throw it like this? Okay, I can throw it like this. So at this point it will be very high. And then it will sharply dip like this. Okay. So the range will not tell me if the goal was scored or not. What will tell me? That when it reaches the goal post, what is its height? That will tell me if the goal was scored or not. Is that clear? Okay. Can you find that out? Try doing that. Uh-huh. Do we have to use the equation? Good question. How else are you going to do it? Any of the formula does that fit this description? Any of the formula we have, do they fit this description? Uh-huh. Okay, so that is equation of trajectory. You can use that, yes. Equation of trajectory you can use, certainly, yes. You are absolutely right. Or you can use the equations of motion. Okay, so all I need to do is break this into two components. That's it. This is another form of two-dimensional motion. Is that right? Okay. Tell me what will be ux. Tell me what will be ux. Ux will be 64 by root 2. ठीक है. What will be uy? 64 by root 2. Right? ठीक है. What will be ax? 0. What will be ay? Minus 32 feet per second square. Very good. Alright. What is x? 120 feet. Very good. And what is y? Y is how much? That is what we need to find out. Excellent. Take it. We have uy, we have ax, we have, no, we don't have y. We need to find out y. What is missing here? What is missing here? Excellent, t is missing here. So what is the first objective? To find out the time. Okay, take it. How can we find out the time? Excellent, excellent. So x is equal to u cos theta into t. That's it. Because in the horizontal direction the velocity is not changing. Take it. So this will become 120 is equal to, what is u cos theta? 64 upon root 2 into t. So the time will be how much? 15 root 2 by 8. ठीक है? So time will be 15 root 2 by 8 second. Any problem? Now all we need to do is, exactly, alright. So this will be how much? This is u sin theta. What is u sin u 64 by root 2 into time. What is time? 15 root 2 upon 8, and then minus half into 32 into then t square. T square will be, I should write it there. So y will be equal to 64 by root 2 into 15 root 2 by 8 minus half into 32 into the time square, and that is 15 root 2 by 8 into 15 root 2 by 8. Okay? Is that clear? Okay? There is nothing new in this. You know this already. 2 dimensions. That's it. Alright. So if you solve this, what do you get? 7.5? Sure? Excellent. So 7.5 feet. Has the goal been scored? Yes. Excellent. Alright. There's another way to do it, which might be simpler. Take it. Using what? So all I need is, what is y at x equal to 120 feet? Is that it? That's what I require. So why can't I use the equation of trajectory? What is the equation of trajectory? X tan theta minus into 1 minus x upon r. X tan theta into 1 minus x upon r. Take it. You can use the other one also. Take it. But this is more easy to remember. Take it. What is the range? Can I calculate the range? How can I calculate the range? U square sine 2 theta by g. That's it. What is the range? U square sine 2 theta by g. So sine 90 degree 1. U square कितना होगा? 64 into 64 upon 32. So that will be 128 feet. Is that clear? Range. Now all I need to do is substitute it there. So y is equal to x. What is x? X is 120. What is tan theta? Tan 45 degree yani ki 1, and then this is 1 minus x. What is x? 120, and this is, the range is 1. That's it. So from here you will get 7.5 feet. Clear? Any problem? Take it. Okay, so I understand that it's been a long day, right? For you and for me. Anyway, let's finish this portion of projectile. Take it. Just a few things remaining. Take it. Circular motion we'll skip for today. It's a very small part is in kinematics. Take it. Just centripetal. What is centripetal acceleration? What is tangential acceleration? So if anyone has a test, they can come to me separately if they want. Take it. Yeah, today. It'll take 15 minutes. All right. But I want to finish this portion on projectile motion. All right. Okay. So just 15-20 minutes. Bear with me. Alright, so the range is, listen, range is equal to u square sine 2 theta by g. Alright guys, last 20 minutes, 20-25 minutes. Alright, range, u square sine 2 theta by g. When is the range maximum? If for a given speed, for different angle of projections, when will range be maximum? When sine 2 theta is maximum. When is sine 2 theta maximum? When 2 theta is 90 degree. You're absolutely right. So theta is equal to 45 degree. Do you understand this? Okay. For theta is equal to 45 degree, for a given speed of projection, the range will be maximum. Is that right? Okay. Now understand this. Understand this. For a given range and for a given speed of projection, what am I talking about? I am talking about a given u and a given r. Okay? For a given u and for a given r, I'll have two angles of projection. One will be called alpha, the other will be called beta. For example, I'm throwing it with 10 meter per second and the range is, let's say, 100 meter. So I can throw it at two angles for this to happen. Right? I can throw it at two angles for this to happen. Alright? Visualize this. Okay? For example, I throw it at an angle alpha and it reaches here. Okay? Okay. Now if I increase this angle, what will happen? The range will increase or decrease? Let's say this alpha is less than 45 degree. Alpha is less than 45 degree. Alright. If alpha is less than 45 degree and I increase the angle of projection, okay? So will the range increase or decrease? Increase, because the maximum range happens at 45 degree. Do you get this? So this is going to be somewhere here. I increase the angle even more. It's going to be somewhere here. Alright. At one time it will reach 45 degree. So suppose it reaches 45 degree here and it reaches here. So let's say this angle is 45 degree. Correct? Okay. For 45 degree the range is this. Now if I further increase the angle, what will happen? Range will decrease. Further increase the angle, decrease. Further increase the angle, there will be a certain angle when this range again becomes this one. Is that clear? So for same angle, for same speed of projection and for same range, I'll have two angles of projection. Is that clear? One I'll call alpha, the other I'll call beta. Now the question is, what is the relationship between these two? Okay? How do I find the relationship between these two? The range will be u square sine 2 alpha by g. Can I also write it as u square sine 180 degree minus 2 alpha by g? Does it make any difference? 180 minus theta is sine theta. Sine 180 minus theta is sine theta. Okay. Now this is the range at angle alpha. Will this be the range at angle beta? Will this be the range at angle beta? Okay. And both of them will be same. The range will be the same. Is that right? So now can I compare these two? If I compare these two, what do I get? I get 180 minus 2 alpha is equal to 2 beta. So that will give me alpha plus beta is equal to 90 degree. That means when this happens, both the angles will be complementary. Is that clear? Okay. Point number one, maximum range happens at, for a given speed of projection, maximum. You don't need to write it down. It's there. It's there in the notes. Take. For a given angle of projection, for a given speed of projection, the maximum range will be at 45 degree. And for a given speed of projection and a given range, this will happen for two angles. And both the angles will be complementary to each other. Is that clear? Okay. Now attempt the last question of the notes. It has to reach the boat. So if it reaches the left end or the right end, it has reached the boat. No, no, no. The boat is like this. The boat is like this, and the person is here. The person is throwing like this. Range is between 5 and 6 meter, right? But the range of angle of projection is asked, or the minimum and maximum angle of projection is asked. Anywhere. They, huh? It has to reach the boat. That's it. Huh? Take G10. Hmm. Minimum is 45 degree. Sure. Minimum is 45. No, I don't think so. I think neither max or min will be 45. Max is coming 53. No. Uh huh. 37 by 2. Yes, that is one of the angles. All right. Okay. First of all, if it has to reach this end, listen. If it has to reach this end, the range is how much? Range will be how much? 5 meter. 5 meter, no? Okay. So this, if it reaches the left end, the range will be how much? 5 meter. So if you put in all everything, what would you get as theta? Could you calculate this? The range is 5 meter. That is equal to u square. U square matlab 10 square into sine 2 theta divided by g. Is that right? Uh-huh. So sine theta is how much? Sine 2 theta is 30 degree. Sorry, sine 2 theta is half. Then 2 theta is 30 degree. So theta is how much? 15 degree. So you'll get a successful shot at theta is equal to 15 degree. You're right. Now let's increase the angle. Let's increase the angle. Suppose it reaches the right end. Take it. Then what will be the range? 60 range would be 6 meter. And then if we calculate the angle, what will be the angle? This will be equal to 10 square sine 2 theta by g. This cancels out. So sine 2 theta is 3 by 5. So 2 theta is 37. So theta is 18.5. Do you get this? Is that clear? (37 by 2). 2 theta is 37 degree. So theta would be 18.5 degree. Now is this the answer? The minimum angle 15 degree, the maximum angle 18.5 degree. Is that the answer? Absolutely not. 180 क्यों? Right. So if I had a successful shot here, I had a successful shot at 15 degree. So it also means I'll have a successful shot for another angle, 75 degree. Yes, so I'll have a successful shot at this end with 15 degree as well as 75 degree. Is that right? Similarly, I'll have a successful shot at this end with 18.5 degree and 71.5 degree. Is that clear? Alright, so now listen carefully. What is the range of angles for successful shot? What is the range of angles for successful shot? So I'll start with 15. Successful, successful, successful. What is this angle? 18.5 degree. This angle is 18.5 degree. What if I increase the angle from 18.5 degree? Out, out, out. Okay. Then it will reach 45 degree maximum. Then if I increase the angle, it will again come back. When will I get a successful shot? 71 degree. 7.1.5 degree. And then if I increase the angle, will I get a successful shot? Yes. Till I get 75. So these would be the range for successful throws. Alright. But what is the minimum? This is the minimum. What is the maximum? This is the maximum. Is that clear? Alright. Okay, so we meet on Saturday. Saturday 1:30. That's what we discussed. Right? Saturday 1:30 p.m. Alright, those who have exams tomorrow or in a couple of days, at least you can solve NCRT and go for the exam. Okay? I'm sure you'll be able to solve at least 90% of the questions. Alright. Those are not in a hurry of any exams. You have the assignment with you. You can start with the assignment. आधा हो गया? Very good. चलो. Alright. चलो. See you